Well, hey there. My name is Mike James. I'm president of RiskBase, and I just wanted to go over a little lightweight risk assessment tool that we've been working on customizing for a different site that have either kind of expressed interest in us or that we wanted to deliver so you could check out and hopefully make use of it. So the way this risk assessment tool works is it is customized to each site. So if we had, if we are sending this for you to check out, we've done research and analyzed local meteorological conditions for that area in order to determine what the predominant weather conditions for that area are to really help us get a good feel for potential risk and potential hazards to people that are within occupied buildings for the site, and to determine real accurately what the impacts could be. So as the yellow sign says, we're going to start here. And the first thing we're going to do is we're going to enter in, distance from different release points to to occupied buildings. And so you can see here, well, we can put in a number of different chemicals, temperatures, release type. And so we can do pipe releases, tank releases, pump leaks, kind of standard stuff. So let's say we are going to first model up. Let's say we have our ammonia tank. So we're going to put in ammonia. And we'll just use ambient conditions. Let's say we have an ammonia tank. And let's say that it's 300 feet from a control room. Let's say the control room has 10 people inside of it. So we're going to want to assess the impact to that control room. All right, so now we'll scroll over. So you see that the tank release fields are open and the other fields have been blacked out. So we know which ones to target. All right, so we'll say we have a 10 by 10 ammonia tank. We'll say there's 7 feet inside of it. It's just stored under its own vapor pressure. So like the sign says, we can leave that alone. We'll say it's a 2-inch leak, 3 feet off the bottom of the vessel. All right, so let's scroll back and let's see what the results are for this. So one thing it tells us are distances to the emergency response planning guidelines, or ERPGs, which are different concentration limits of interest. And they're defined for specific highly hazardous chemicals. So for ammonia, this would be the distance where we'd see that level 1 impact or nuisance level. So pretty far distance. These are the worst case values based on very stable weather conditions. And then these are the distance to level 2 impact, which would have variability to escape, and level 3 is potential for fatality. So these are your very potentially hazardous conditions. So based on the meteorological patterns and predominant weather conditions we noted for the facility, based on distance to this, there's an 8% chance of fatal exposure inside of that occupied structure. And so we also looked at estimates for failure frequencies. And so when we kind of look at, what's the individual risk? That would be, this frequency times this probability. That's what we get for this value. And it's similar to what you'd see in a quantitative risk assessment, but just to give you an idea of magnitude of, risk. And then this is societal risk, which is just effectively that individual risk multiplied or scaled up by your occupancy. So that's scenario number 1. Let's go ahead and we'll enter in another scenario. So let's say we have a 50-pound chlorine header. So I'm going to punch in chlorine. We'll use 77 degrees again, just stick with that. And we'll use a leak from our piping header. All right, so everything else is blacked out. We just have our piping. So like I said, it's a 50-pound header. We'll say we have, something from an 1.5-inch nozzle, say. And we'll just have it released for 15 minutes. And we'll say that it's, let's say we're 500 feet from an admin building. So we have 30 people in our admin building. And based on those just few inputs, we can estimate, well, we have a 5% chance of fatal exposure in that building. We have an idea of our frequency. And this gives you an estimate for my individual risk and societal risk. Right now you can see, well, based on the differences here, this chlorine header poses a 10x higher risk than that ammonia header does, or that ammonia tank does. So it's not good to give us that comparative risk assessment. And then let's also look at another scenario. Let's say, for example, we have an HF pump. So coming out of our HF tank, we'll stick with that 77 degree. We'll stick with ambient conditions. And now let's do a pump leak. So let's go on over. Our pump normally flows 300 GPM, and we're discharging at 20 psi. We'll say we're able to stop the leak in 15 minutes, and we'll look at a seal leak. So we could also do a guillotine break, but we'll just look at a seal leak from this. Let's see what that looks like. Right, and from this building, let's say we have a satellite room, which has 2 operators, and we'll say it's about 100 feet away. Okay. So we have a 4% probability of fatal exposure in that building. You can see our distance to our ERPGs. You can see our societal risk. From a societal risk, it's about half the risk is what we were seeing with our chlorine scenario. So the chlorine scenario is definitely driving for our site right now, and the HF is posing a similar amount of risk. Let's go ahead and we'll add one more final scenario. All right, so let's say we have our benzene. Let's say we have a benzene pump, and we'll say it's at high temperature. So we'll say 250 degrees F, and we'll look at a leak from a pump. Let's say we have a really high flow benzene pump, discharging at 100 pounds for 1,000 GPM, and we'll say we're able to stop the pump at 15 minutes, and we'll assume that it's a guillotine break. So let's see what this scenario poses, and we'll say that we are also looking at impact of that first control room, but in this case we're 500 feet away. All right, so here, even though we have a very strong, powerful, a very hazardous release based on the toxic exposure, at a 500-foot distance, we see that we have a 0% probability of fatality and a very low individual risk societal risk. So hope you're able to get used to this little simplified tool. Again, it's very customized for studying impacts to your site. Currently, it's restricted to just looking at toxic exposures, which is, if we were to engage a site, we'd be able to further build that out and analyze much more conditions. All right, well, thank you for